Hello everyone, I'm Rinku Dhiman, working as an assistant professor in electrical engineering department at RP IIT Technical and Medical Campus, Karnal. So today we are going to discuss about the optical devices. As its name suggested, optical is related to our light and light intensity kind of things. That is basically used in transducer to detect some other quantities. So optical devices is nothing but that is based on the principle like many measurement and control system utilize the light and light intensity as a way of detecting other physical properties. So here we will use the light and light intensity properties in different kind of measurement and control system to detect some other kind of physical quantity, say temperature, pressure, humidity, and etc. And same way optical so using the direct or reflected light can be provide an ideal non-conducting contacting sensing mechanism. So in this kind of devices we don't need to a manual contact with the device which we are using to measure and component. Okay, so we don't need any direct contact with the device. So without any contact we can measure the quantity or physical quantity which we want to measure. So the best example for this is a photoconductive principle. So these are nothing but a semiconductor cell which produces a change in its resistance in response to change in light intensity. So we'll put a resistance in the device. As the light will fall on this, as the light intensity will be changed, resistance will be changed and directly give the measurement of the quantity. So three most common photoconductive transducer are using LDR, that is the light dependent resistor, phototransistor and photodiode. So when we will discuss all these kind of photoconductive devices. So first of all LDR, that is the light dependent resistor. So here we will put a light or light intensity from the source on a diode basically. So this is the diode basically. Okay, or we can say that we are replacing over here this diode with the resistor. So we don't need to make any contact with the device at the measure end. So we will put a resistance and the light will be put on this resistance and the light intensity will be changed, the resistance will be changed basically. Okay, so either it will be increase or decrease, that is depending upon our coefficient of resistance. Then LDR, that is the light dependent resistors, are basically a semiconductor device, right? So its resistance is depend on the light intensity that the fall on the device. So resistance basically depend on the light of device. If the light intensity is high, resistance will be less. If the light intensity is low, resistance will be more. So more will be resistance, less current will be flow, and it will give the less deflection of the reading. So LDR basically as the light intensity increase, resistance of the LDR will be decreased. So it will give a negative coefficient of resistance, we can say. So if you will see over here, it is a non-linear device. LDR is a non-linear device, we can say. As the resistance will be decreased, light intensity will be increased. So light intensity will be increased, resistance will be decreased. So resistance and light intensity have a reciprocal characteristics or reverse characteristic, we can say that. So LDR is a non-linear device and with the resistance range of 10 milliohm in complete darkness, it will give that 100 ohm in a full sunlight basically. So that is the reciprocation of your light light intensity and resistor. Thank you very much. This is all about the LDR and photoconductive devices. Stay tuned with us for more videos on transducer. Please like and subscribe our channel. Thank you.